There are several types of numbers we could look at with the temperature, means, and ranges. A daily range. What's the difference between our high and low in a day? Again, that's going to be helpful in terms of, do I need my jacket? Things of that sort. We can look at this a longer term. For a month, for a year. What's the mean, the average temperature? What's the range? Difference between our high and low. This reflects some of the confusion relating to global warming as well. You often encounter where somebody says, yesterday was really hot, must be global warming. Or, yesterday was really cold, there must not be global warming. Well, no, neither of those is correct. Those are looking at a particular part of the range of temperature. But what global warming is talking about, it's saying that our mean for the whole Earth is gradually getting somewhat higher. Okay. To check that, we need lots of data for many, many days to see if we are seeing an increase in the average, not one hot day or one cold day. I mean, there are hot days, there are cold days. That happens all the time. That's not telling us anything about global warming. What we need to look at is long-term trends. For example, if we see noticeably more days that are rather hot and fewer that are very cold, that would be an indication of global warming. And we do, in fact, see that. But just one day was really hot or one day was really cold, that is not telling us something one way or the other. What are the extreme temperatures? The hottest temperature that has been measured officially for the Earth's surface was back in 1913, Death Valley in California, temperature of 57 degrees. It's gotten close to that. Sometimes lately we may see that record being broken. Widely cited record from Libya, 1922, just over that, 58, or 136 degrees Fahrenheit. Turns out that one is incorrect. Despite the chaotic situation in Libya these days, someone actually was able to track down, find out just where that thermometer was, find records from it, and confirm that that thermometer was reading consistently too high. So, that is not correct. Now, yeah, it's hot in the Sahara, but doesn't have the record. The coldest temperature recorded for a direct measurement with a thermometer was at the Vostok station in Antarctica. No surprise there. Minus 89 Celsius. Quite frigid there. For North America, the coldest was up in northwestern Canada, in Yukon, Snag being the town, at minus 63, which, well, it's better than minus 89, but that's about all you can say for it. We do have some satellite measurements that suggest greater extremes. The highest surface temperature measurement from a satellite is in the Dasht Salt Desert in southeast Iran of 70.7 degrees, but that is a surface being heated by the sun. That is not official temperature. So that's a problem there for the satellite to measure what we're officially counting it. That was not a temperature in the shade of the air. That was a hot surface heated by the sun. Antarctica, there's evidence of getting a few degrees colder than that measurement from Vostok. Now, there are rare brief weather events that may cause more extreme temperatures. These are poorly documented, however. There are a number of accounts, but given that they are rare brief things, weird temperature readings, it's kind of hard to pin down exactly. How do you get such extreme temperatures? Well, Antarctica, this is in areas of higher elevation. That's going to help lower temperature. less air above, and very clear cold air. That means that heat can very easily escape out into space. It's not going to be trapped in the air and staying around longer. Again, Antarctica, due to the curve of the Earth, only gets sunlight very low in the sky. As we saw, there are multiple reasons why that gets you less warmth to the ground. Colder air tends to sink, and so if you've got a little bit of a valley, denser cold air can kind of sink down and sit there and make things be even colder. Conversely, a very dry desert area, bare soil rock tends to be somewhat darker, good at absorbing heat. Clear air transmits, whether it's losing heat in your cold area or letting that sunshine in. High transmission coming in, so lots of light. And there's not much water, so evaporation of water can absorb latent heat and cool things off.